Hello everyone, welcome back to the workshop, and today we have something exciting to look at, and this is the most powerful diode we've had the chance to look at, and that is the Atomstack A70 Pro. This is a 70 watt diode. You can switch it down to 35 watts if you want a little more detail, but I'm really curious about the cutting power and the speed with that 70 watts power, so we're gonna check that out, see how it performs. So if that's something you're interested in, want to check it out, stay tuned. We're gonna jump right into it. All right, so here we have it. This is the A70 Pro from Atomstack. They were kind enough to send this out for my review. They aren't sponsoring this. They did not pay me for this video, but they did provide the equipment for it. So I'm gonna do my best to give you my overall impressions and the rundown. We'll do some real world tests of what I am seeing it performing in my workshop, and hopefully that can give you some information on if this laser might work for you. So with all that out of the way, I will touch on some of the build. I'm not going to go into a full build review on this. My friend David over at the Clack Shack did include some of that in his video, so I will link down below to his video if you want to check that out. But I will try to touch on some of the points that I felt maybe need a little extra attention or weren't necessarily as clear in the manual. As always, if you have any questions, you got this laser, have some questions about the build or whatnot, hit me up with a comment down below and I will do my best to help you out. So let's look over some of the specifications of this laser before we jump into the real world tests. So there are two different versions of this. This one is the Pro, and this one sits at 400 by 500 millimeters, or about 15 3/4 by 19 5/8 inches of working area. Whereas you can also get the Max, which is an 800 by 850, nearly double this size. That ends up being about 31 3/4 by 33.5 inches of working area. Now the actual physical dimensions of this one, front to back, including this magnetic offline controller, you're looking at about 31 inches or 790 millimeters front to back as far as clearance. Side to side to make sure you clear the rails and whatnot, but not including the air pump and the power supply. That's going to sit about 28 inches or 710 millimeters. So if you were looking at, will this fit into your existing enclosure or something that you can build, you're going to be wanting to look at something probably about 32, 33 inches deep, because you're going to want some extra room for cabling. You don't want things just jammed in there. And I would say somewhere around 30 inches wide. Now, I personally like to build a little bit bigger than that, give myself some room for cabling and maybe some fixtures and such. But hopefully those dimensions help you out in planning, will this fit in your area or something that you need to build for it. The overall build is really decent. It is made of some custom 20 by 40 millimeter extrusion. It is fairly hefty. It's not light by any means, but does have more of your typical kind of bolt in together extrusion connections and such. So that did go together fairly well. They provided all the screws and bolts kind of in sequential order, and didn't have any problems there. The belts, they are upgraded. They over your standard 6 millimeter belts, these are 9 millimeter belts, so they give you a little extra heft to that. You know, this is a larger gantry and such, a little bit heavier module, so it's got to sling that around a bit. It's good to see some better belts on that. They do have cable chain on both axes to help maintain cable management, and then a few attachment points for the actual module itself. Everything is tucked away very nice and seems to work well. Along with that control system and the extrusion, they also have these steel rods and steel wheels. That is kind of an upgrade over the kind of the Delrin or poly wheels that you see on these that ride in the channels. You will need to keep these clean. You will need to add some lubricant from time to time, but they shouldn't wear as much as the other style we've seen on earlier lasers. The front stepper is in the middle and has your timing rod going out both ends. They are captured with some anchor points out towards the ends, and then they connect to the sprockets on the outer ends. You do want to get your belts tightened properly. They do have some tightening blocks in the back. You can loosen up and tension these. You want them just snug enough that everything is moving without skipping, but not so tight that it's adding extra strain on the motors and or on these pulleys. So outside the actual frame itself, I did mention earlier, they have a very large external power supply. This isn't integrated into the controller in any way. It does have your typical PC input cable, and then it has two outputs on it. One is 36 volt and one is 24 volts. Those do get plugged into the control box up front here. I do like that all the cables are on the side here. That gets them out of the way. And then out from here, they do have an additional output of 12 volts that goes into the air pump itself. This is nice that everything is powered through that one power supply. You don't have extra cables that you need to plug into the wall or your power strip. And having this through the controller here means that that is controllable through Lightburn and other macros on other software. So you can turn on and off by layer your air assist. The air pump itself is their standard dual pump 30 liter a minute unit. I've liked these on many of the other Atomstack units I have. It does have a variable speed up on top and does seem to work very well. As far as the control box up front, as I mentioned, they do have the cables off to the side, which are nice. There are a few buttons on top. We have our on-off button. We do have an autofocus button because this laser does have a Z addressable motor on it, and so that can autofocus either through the software or through the hardware. They have an alarm light and then a USB drive input and a reset button. Now the USB drive is for when using the offline controller. You can power this up and select your file and use it standalone without a computer, or you can actually detach this whole thing, take it out of the way, and just connect it up into Lightburn or Laser GRBL. Now, when working with this on the computer, they do provide a USB-C cable. There's a USB-C input on the side, and then they do provide your typical A and C adapter on this end. However, this cable is only about 3 feet long, so if you need that to be longer, you can run it off of a typical USB-C cable. I've done that with my laser and my laptop, and so no problems on sourcing a longer cable if you need. But it's nice that they provide one that has both connections, as you're starting to see more and more laptops switching away from the old style into the USB-C style. So as I did mention, one of the features of this laser is the autofocus function. So this is something where it has in the back of the module a little touch off button, and it will lower the module down, touch off your material, and then do the appropriate offset to get that in alignment. Now, one thing that I noticed when setting this up is you do need to make sure that your module has enough distance to travel for when doing the autofocus. The higher your material is up and the sooner it hits that, it'll have a tendency to air out and give you a hard limit stop. This happens a lot too when you have your honeycomb elevated from the base of your laser. So as you're planning this out, if you're building this into an enclosure, I would definitely try to make sure that your laser can either be blocked up or your honeycomb recessed down so that the top of the honeycomb is recessed to be level with the bottom of the feet. That'll help you out. Then you want to make sure that your module is really zeroed out, that it's down on the side, that it hits zero when it touches this bottom surface. As I did some initial testing, I was struggling with getting the autofocus to work right until I got that lined up. And then I found as I was using real thick materials, if it didn't travel far enough, it was airing out. So just make sure you have enough depth for it to fully go down, touch off that, and go back up so that it doesn't air out and cause you some hassles with autofocus. Once I got that figured out, it has been rock solid, and so I've been appreciating how well this autofocus has been working. Now, if you don't want to use autofocus, they do provide you with this manual focus block. It's got 3 different steps on it based on top level focus for engrave, cutting materials less than 20 millimeters, and cutting materials greater than 20 millimeters. So you would bring the module down. You want the base of this shroud to touch off whichever level you're using. And there's just the knob at the top of the module that allows you to bring that focus up or down manually. So 2 different options if the autofocus isn't working for you or you just want to dial in your focus yourself. Nice to have that block and have that option to do that as well. So as far as safety on the module that I mentioned earlier, they have this shroud at the bottom. This is removable if you need to get it out of the way. It will still leave your autofocus bar in there, but that will hang out a little bit. But they do have the protective glass in the front. And as I mentioned earlier, this does sit up a little bit higher due to the longer focal length of the laser lens in there. And that can cause some issues with light bleed through. So if you're using this in the open format, they do provide you some glasses that will add a layer of protection. Now, as with always, if you've watched any of my reviews before, I'm not a fan of these included goggles. They are better than nothing, but they do not have a specific rating on them, and they don't always fit well over prescription glasses or different size heads. So I strongly recommend you take the extra step and buy some properly rated goggles. I have a link down below to some that I use. You'll see on those that they have the actual rating etched on the front. So you're looking for something with this laser specifically that it protects from a 455 nanometer wavelength. And then you're looking for something at least of an OD of 4. The optical density is the amount of light it actually blocks. The goggles I use are actually a 6+, so that gives a very high level of protection. Protecting your eyes is very important. This can cause damage. to your eyes by the brightness of the light as well as the wavelength, so it's good to protect your eyes. Second option is, of course, to build an enclosure for this, and that is something I plan to do in a future video, and then we'll incorporate some glass into that as well. The other things to worry about is fume extraction. So if you're using this as an open area, you want to make sure you have ventilation through your shop or maybe using it outside. But if you're using it enclosed, you do want to try to capture that and then vent this out. Again, we're going to be building an enclosure in a future video to cover that. The other thing that does is when you can extract the air from here, it will help keep your module clean. This does have a fan on top, and that pushes air through to keep the module cool. Also help move some of the smoke and debris away from the end of the unit. That is a feature that they've improved on this one over past ones. They actually have that fan modulated. So when the job is running, the module is hot, it's actually moving more air, but when it's cooled down and the job is done, it actually turns that fan off. So that helps make this a little more enjoyable to be around when you're just having it sit idle in between jobs. You don't have this loud fan running. The caveat to that though is it's easy to leave your laser on at that point. So your only indicators at that point will be there's a light on the on-off switch and possibly a light on the alarm if it's triggered. But do be mindful that you don't leave this powered on for too long if you're not using it. That power to the steppers can wear them out over time, and it's just an extra danger and a waste of electricity. So, but it's nice to see the enhanced features there with that fan being controlled. Just makes it a little more enjoyable. So with all of that overview done, what I'm going to do is jump into testing this laser out. And we're going to be focusing primarily on the cutting ability first, but we're going to touch on the engraving. We'll take a look at the kerf and such and see what we can do with a few things on it. And at least give you an initial overview of what this machine might be able to do over your current laser, or if you're looking at this as your first one. So let's jump into the testing. So longtime viewers of the channel will know that I like to use 3mm Baltic birch as kind of my analog, my baseline tests for lasers. This isn't your typical craft plywood that you're going to find in hobby stores and such. This is more of a cabinet grade plywood. I've used it for a lot of my builds in the past between lasers and CNCs and even just normal woodworking. And so I use a lot of it, have a lot of it, and it works out well for me. So keep that in mind when comparing this to maybe your material. But you can go back and look at my other videos to see how this compares. And here is the results of our cut file. You'll see at the top there, we were squeaking out at 1200 millimeters a minute, or that would be about 20 millimeters a second, and getting through at 100% power. But we were still cutting through even half that speed, 50% power, we were getting through at 600 millimeters a minute. So definitely a step up from the other lasers, or getting into some higher speeds there. I would say definitely could run this at 1,000 to 1,100. I always try to back it off a little bit just in case there are some of those fibers or denser spots, and have some pretty good success cutting through this. Now, of course, this was with full air off the stock air pump, and having that air assist definitely helps improve that. So from there, I stepped it up to something a little more typical that I see people use, and this is kind of like a 5mm Luan or flooring board. You can see on the back, it's got some of those X's and such. And this is a little bit lighter weight material than the plywood, so we're not going to see cutting in half, but we are still getting through a little bit slower, but up to 900 millimeters a minute at 100% power. So there again, we're going to be in that 15 millimeters a second range. And then down to 600, we're still getting through at 60% power. So just something to keep in mind, that as you run through different types of material, you're going to want to run tests on it, because we did not drop in half from the 3mm up to the 5.5mm stuff because of the density of the plywood. So of course, we also want to test the engraving on these materials. So again, jumping back to the Baltic birch, and this was all on the 70 watt setting. Did a test engrave here, and you'll see we got some pretty dark numbers down there in the lower part on up to a little bit lighter in the top. We did this from 12,000 millimeters a minute up to 24,000 millimeters a minute. Getting some decent gradients. Definitely very hot down here at the 100% power and 12,000 millimeters a minute. As a matter of fact, I would say it went through a good, probably the top third layer of this plywood. So if you're looking for a deep engrave on material, something that maybe you could infill with a thin layer of epoxy or something else, definitely this machine is going to be able to do that on that 70 watt power setting. It is going to leave some overburn there, so you're going to want to have to be able to sand some of that off or something to clean that up. And then as we get up to the 24,000 millimeters a minute, we're really not getting anything at 10. As a matter of fact, really didn't get anything going at 10%, maybe just a bit down there at 12,000 millimeters a minute. But it kind of just fading off at the 20%. So I'd imagine if you're setting this up for photorealistic engravings or needing that gradient, you're going to want to have your range go from 20 on up if possible. So, but overall, we do have a nice gradient and a little bit of color drop off there in the tone of the wood, and definitely something you could use for. Now, jumping back to the cutting ability of this laser, wanted to see how it could perform on some 1/2-inch plywood. So this is your typical stuff that you can get. I believe this is from Home Depot. It's got the 3 layers with the 3 inner layers with the thin veneers. So technically 5 layers of material to get through with the birch on top and bottom, and then more of like a poplar center. So this is going to be fairly ideal for cutting. It's not as dense in the middle. Just have that thin veneer on the top. So I started at a few different settings. Started at 1 pass at 375, stepped it up to 400, and then finally got through at 350. And so here you see the cutout here. It's at 350 millimeters a minute, single pass with full air, and it's cutting through pretty good. Not a lot of charring there. It is definitely caramelized, but not so much that it's going to burn off a lot of soot on your project. And as you can see on the back side, if we can get this focus, fairly clean on that side as well. And you see the other two, they wanted to get through, but not quite. So it's not always about doing it in a single pass. You can sometimes get a cleaner cut by stepping up your speed, and sometimes, or your speed and your passes, and then sometimes get even faster cuts. So I started up at 900 millimeters a minute, 2 passes, and then just kind of slowly stepped it down till we got to 800 and 2 passes. This one cut out again, and as you can see here, fairly clean, nice and caramelized, not too charred. And again, here is the backer. This one just wants to come out at 850, but really had to step it down to the 800. But again, fairly clean, just a little bit on each side where it starts and stops the cut, where it burned through and left a little mark. So 1/2-inch plywood at 800 millimeters a minute, 2 passes, that's pretty good. It's moving through the material. I think it's realistic. You could actually cut out some parts. So with that, I had to try it on something realistic. And so went ahead and burned one of my logos into this 1/2-inch plywood. And this is probably about 6 to 8 inches in diameter, give or take. And it worked out very well. The burn was nice and just deep enough. It has a little bit of a depth to it, but not so deep that it is going to create deep crevice and such in there. Nice consistent burn through there. And then the cut as well. It looks very nice and clean. Let's see if I can get focus on that and not me. Here you go. Nice and clean cut there. And everything dropped out. Just a little bit of spots from the honeycomb, some flashback on the side that would be easy to take out with a sander. But this is finally starting to get into where you have thicker material that you can cut it out in a reasonable amount of time. So then the question is, how does it do with hardwoods as opposed to plywoods? With hardwoods, depending on their density, you can actually get through them a little bit thicker material because they don't have those glue layers. They don't have the alternating patterns in grain. It can sometimes be more forgiving. And so I had the neighbors had taken down a cherry tree last year, and I had kind of cut off some of the branches and other things to try to salvage and use. And so I had these cookies that were in there, and I thought, hey, let's put one in there. This one had a crack in it already, so figured let's try cutting that in half. And so I ran it at 100 millimeters a minute, 100% power, and it did in fact cut in half. There were just a few spots where it was holding on. You can kind of see those white areas where it didn't quite cut, but it was just a matter of breaking that loose. So possibly adding an extra pass or playing with the focus a little bit more. There's a number of ways to get through this, but wood is also going to be slightly inconsistent. They're going to have some tough spots to it. So that's where you got to play around with this. But this being at about 19 millimeters, a 3/4 inch, worked out fairly well. Now that is a very risky cut at that speed. That's thick material. There's only a lot of flare up. It's a slow speed. So I would honestly recommend playing around with your material, probably getting it up somewhere in the, at least 150, maybe 200 millimeters a second. So double your speed on your, add an extra pass, and that'll hopefully make this cut a little bit safer for you, but definitely something that is doable with this laser. Now in their advertising specs, they do claim that this can cut through 25mm acrylic. Now, I don't have any acrylic that thick, and I don't really know that that's a practical use for this. You know, most people using with acrylic are going to be using some thinner stuff. Can it cut through it? Probably. You know, we got through that 3/4 inch material, so getting through maybe an inch thick piece of acrylic would be possible. But I wanted to try something a little more practical. So this is closer to 1/2 inch material. Maybe I think it's actually closer to maybe 3/8. So we're going to call this about 9 to 10mm acrylic, 3/8 inch. And so I started doing some tests and running through it. And you can see I've got a number of circles in there where I was testing this out. And I did eventually get through, when I slowed it down, to about 150 millimeters a minute, single pass and full air. Obviously, this would be much better if you added multiple passes, maybe use that Z addressable and stepped it down on those passes to get a faster, cleaner cut. It is okay, but as you can kind of see here, it does leave a less than stellar polish. Now that could also be just this specific acrylic. This is a sample piece I have. Different acrylics will polish a little bit better with different lasers. So definitely something to play around with the material, but it can get through it in a single pass if needed. And if you have a need for that, that would be something you can look at. Most of us are probably going to be sticking to the thinner acrylics, using them in more decorative things, something around 1/8 to 1/4 inch. So hope to do some more testing on that in the future, see how it cuts through that. Now the caveat with acrylics is it doesn't matter whether you have a 5-watt diode or 70-watt diode, you're not going to be able to cut through clear acrylic or transparent acrylics. You're going to struggle with some of those that maybe are a color, but they're not fully opaque. That has to do with physics. It's not amount of power you throw at it. It's just that the light passes through it. It doesn't interact with it. Now you can melt through it with using binders such as paint, and you're going to get through it maybe at some point. And you can definitely engrave by adding that coating to it, but you're going to struggle and possibly not be able to touch anything that's really bright white. That is a very light color, especially if it's clear or translucent. So I know some people are going to ask that, can this cut through clear acrylic? Diodes are not your answer for clear acrylic. Now this is a switchable power supply, and so what you can do is turn that down from 70 to 35. That basically disables half the diodes in the module. And why you would do that is it actually helps shrink the spot size. Those individual diodes emit a single beam, and then the lens kind of combines them together, but there is overlap and it spreads out the bigger you get. So what you could use this for is if you wanted a more detailed engraving, that reduced spot size would help give you a little extra detail at the loss of some of the light power coming through there. So I wanted to do a comparison test on the 70-watt beam with a smaller laser. Going down to 30 watts is helpful, but I wanted to step it down to something closer to the 20-watt range. So if you've watched this channel before, you know I use the Atomstack A70 as kind of my mobile laser, and it works pretty well, has a fairly compressed beam. So I ran a test on a piece of plywood, first on the A70 with the 70-watt power setting, and then jumped over to the A24 to run the same test and cut out some squares that we can measure to get an idea of the kerf that's cut through here. So as you can see here, same piece of wood. Up at top, we've got the A24. Down at bottom, we have the A70. And ran these at 25mm squares, and then measure both sides and average them out across the 4 to get the kerf in both the horizontal and vertical axis. And so that helps us get an idea of the relative spot size. I made sure to focus the same at the top of the material on each one, and use the same piece of material to be as consistent as possible. I'll throw in a photo here. You can kind of visibly see that the A70 does have a slightly looser look when the parts are put back in, but using a digital caliper, we were able to really dial this in and got the measurements. And when I did all the math, what I came up with, the A24, I had a spot size of about 0.45 by 0.41 on average, and the A70 down here on the bottom was 0.51 by 0.55. So we're getting a 20 to 25% increase in size of that kerf. Now, in the grand scheme of things, that 0.1 millimeter difference probably isn't going to mean a lot unless you're trying to do those photorealistic engravings. That 25% larger spot size means a reduction in quality because each individual spot is going to be that much bigger, and then you can get less detail out of it. So really the biggest place that this is going to factor in is if you're trying to do photorealistic engravings. And in that case, you can step it down to the 30 watt. That's going to have a similar output. And I probably should have ran that test, but I wanted to really bring it down to that 20 watt size to get a closer comparison on it. Again, I think they've done a lot of work in improving the focus compression of those beams. I think in the past we've seen much larger beams out of 20 and 30 watt lasers. And so I think they're doing a good job of, as they're adding diodes and trying to compress that into a single beam, they're getting better at that. So this is going to be less of a hassle as it was maybe a year or two ago. But it is still an increase. And so hopefully that gives you a little insight into the difference between those two settings. So this is where I'm going to leave the review for today and kind of our initial impressions. Wanted to focus on its cutting ability, and as stepping up to 70 watts, that's what people are going to be looking at with this. But I am going to be doing more work with this. This is a very nice laser. It's performing well on that 1/2-inch plywood material. So that's going to open up some more possibilities for me in not necessarily having to jump to the CNC router for some thicker materials, being able to do cutouts and engravings a lot easier with this. So I'm excited to use this a bit more, but the first thing I need to do is I need to build a new enclosure for this. The machines are just, they're squeaking out a little bit bigger. Like I mentioned, they do have their max version, which is 800 by 850 working area. That is huge. I just didn't have space for that, so I opted for the Pro, but this still is going to give me a lot of working area. So I am going to take you along as I build that enclosure. That will hopefully be coming out shortly because I want to be able to use this more, but use it safely. And being able to get that in an enclosure, be able to exhaust those fumes and protect that light, it's going to be huge for me. So stay tuned for that. I'm going to try to build that as economically as I can with as basic of tools as I can, just to show you that you can do it too, and be something that will definitely help you out if you're just getting into lasers. So if you are interested in this laser, I will have links down below where you can check it out and purchase it. Those links do tell Atomstack that you appreciated my content, and gives me a slight little kickback as well, no additional cost to you. So I appreciate you using those, but as always, no pressure. I also have some links down below to some other items that I like to use in my shop with the lasers and whatnot. Some of those will be Amazon affiliate links. Again, they do provide a little kickback to me at no additional cost to you. If you have any questions or comments about this laser or anything else you've seen in my workshop, go ahead and leave a comment down below. And if you felt like this was good information, you're new here, I'd appreciate that like and perhaps a subscribe so you can catch future content. Anyway, as always, I appreciate you watching my videos and hope that you got something out of it. But most of all, I hope you can get out in your workshop and make something too. We'll catch you next time.